Hey everybody, Lars here. If we remember 2 weeks ago, and if you don't, go look for the video, we looked at Project Euler. And Project Euler, if you remember, is a site that has 700 number theory problems, and they lend themselves to being solved with computer programming. We created an account, CS111 F2020. The password is Java class. And you can go in and you can do any of these solutions. You remember, if you click on a solution and you've done it already, it'll show you the answer right there. So if you recall, we looked at number 6 2 weeks ago. And we wrote code with the tools that we had at the time. We had simple data types, we had conditionals, we have looping, and we put together a program that basically did this worked example, because they show you a worked example for the first 10 natural numbers, and then they ask you to do it for the first 100. Well, because we did it in programming, it was easy. We just took the 10 and we made it 100. We reran the program, and we got the numbers we needed. And if you remember, you do the sum of the squares, then the square of the sum, and you take the difference, and that's the answer. Okay? If we go back and look at the code that we did, you'll remember we got the description of the problem, and we put it right there in the code. We called it, what did we call it? We called it Euler 6. We take the number from the command line that we're going to use as our limit or our n. So at first we did it for 10. We'll run it and show it. Then I grabbed two variables, sum of square, which is what SOSQ stands for. I initialize it to 0. Same with square of sum. And then I start finding my answers. Sum of squares, I jump into a for loop. And I create an accumulator where I accumulate the squares. Okay? So that's the sum of the squares. Then I print it out just to check my result. Next step, I want to find the square of the sum. So I do a for loop. And what do? I just grab the sum, add everything up, and then outside the loop, I do the squaring because I want the square of the total sum. Then I print that out. Then in one line, I find the difference. Okay, so if I were to run this program, Java Euler 6, let's say 10, it's going to give me the numbers that we see in the worked example, 385, 2050, 3025, excuse me, and 2640. All right, so what we really wanted to do, though, is run it for 100. And when you do that, you see the 251, 64, 150. Well, that's our answer. Okay, so we ran it for 100, got our answer, came back to Project Euler, put in the answer, and got that big green check mark. And everything was great. The issue is, and this, works fine, gets us where we want to be, gets us to the answer. But now, sitting at the end of week 7, we know about functions. Now, at the end of week 7, we know about modularity. So now, thinking about what we've read and what we should be thinking, if we can separate out tasks, we should do so. And as I said the first time we went and tackled this program, this isn't one problem. This is 3 different problems. You got to find the sum of the squares, you got to find the square of the sums, and then you have to find the difference. So maybe this is something that lends itself to being designed in a modular fashion or done with functions. What I'm going to do is this. I'm going to grab this code, all right? And I'll remember to do those. And I'm going to copy it, and then I'm going to come here, Control-N for a new file, paste. Don't forget those 2 that get left off when you did the copying. And I'm going to come down here, and I'm going to call this Mod Euler 6, all right? And I can leave the description there. I can leave this there. I will even leave the thing called Euler. Blah, blah, blah. I can leave that. I don't need these guys anymore. All right. I want to rewrite this code so that it does its job with functions. So the first task, let's see, main, I'm going to come in. I'm going to ask for my n. We're going to leave that the same. Actually, I'm not asking for anything. I'm going to give it in the command line. So then the next thing I want to do is find the sum of the squares. So that's what I'm going to write a function to do. So what am I going to do? I'm going to come up here to the top of my code, and I'm going to use what I know now about functions. I'm going to say public static, because it's a static function method. We're going to learn about that. And I want to return an integer, okay? And I'm going to, what do I want to do first? Sum of the squares? Yeah. I'll call it SOSQ. And what I will take is, I should call it N, but it's the same name, so that's bad. I'll call it num. There, that's a nice little go between. I'm going to open my brace. And what am I going to do? Basically the same thing I did last time, right? Let's do this. Don't think I'm going to keep that print. But I'm going to say for int I equal to 1, that is greater than, I want this to be greater than or equal to num now, because that's my variable, I plus plus, and then I'm going to need that variable, I'll just call it s in this instance, s. So let's go ahead and initialize that, because remember, we read expressions from right to left, and I don't want to be accessing something that doesn't exist yet. Only now we're not going to print it out. We're just going to return it. So I'm going to return s. S is an integer. S accumulates all of the squares, and then we return s. That looks good to me. Call me crazy. So I'm going to get rid of this code right here. And I'm going to pretty much do the same thing with the other one, and then we'll test it. So I'm going to copy that code. I'm going to paste it, and now I have two functions that are exactly the same. But what am I going to do? I'm going to call this square of sum. And for this, I am going to just add the I, and then like I did last time, I'm going to say s is equal to s times s, and then return s. Can use the same variables because we're in a different space, remember? And so that's going to return square of sum. That's going to return, now this is sum of square, correct, SOSQ. And SQOS is going to add up all of the numbers and then square the big enchilada and return that. So now when I come down here, and I say find the difference, I want to call the functions. What did I call it? N? I believe that is correct. Do I need that? No, I don't. So now if I save that, where's a Java C? No, I didn't. Well, I'm going to call it mod. Euler 6. Error, file not found. What did I call it? Oh, I never saved it as this. Okay. We will save it as mod Euler 6. All right, and already I have something. Let's see, one error. So I was out of whack with my parens. Open, open, close it, open, close it, open. So there's one at the end, yeah. Now I should be okay. And it seems I am. So now I say Java mod Euler 6, and I'll give it 10. So when I give it 10, it says the diff is 2640, which leads me to believe I am in the right place, but let's make sure and give it 100. And once again, I get 251, 64, 150. And if I come back here to Euler, I see that that is indeed the answer. So that quickly, we've rewritten here. I'm going to get rid of this. Well, I'm not going to get rid of it. Copy X. What I'll do is I'll put it down here. So basically what we did was we come into the program, we read from the command line the one command variable, the variable that gets put in the args. What you're used to seeing is the args, but just to be different, I called it Euler. And we grab that command line variable and we use it as n to send to our functions. SQOS, which is the square of the sum. So square the sum, I send a 10 here. I go through the loop, I add up the numbers, and then I square the result. And then down here, I do sum of square. So when I do sum of square, I come up here with the number 10. I jump in the loop, and here I'm accumulating the squares. And then I do the returns, and it returns it right to the line, and I get the answer. I'm always in the wrong place doing this stuff. All right, clear. And as you can see, I get the correct answer. Okay, so this, to my programmer brain, looks better than what we did before because I've taken my three problems and I kind of have them separated out into different functions. I have that sum square, square of sum, and then I just do the difference right there in that line. But knowing what we know, I can do something even more different than this. I can say new, and then I can come over here and I can grab, let me grab public class down there. Copy, untitled, paste, public class. I will call this Euler lib. Something over there is ringing on the other one. All right, now I'm going to hit S. And I'm going to call this eulerlib.java. And eulerlib.java is going to have two different functions. I'm actually going to compile the thing, though I don't think I have to because it'll do me one. It'll compile it for me when I run the thing. Oh. So it compiles, and if you look over here, you'll see the class file. And then when I come here, don't get rid of that first part. I can get rid of this now. Okay? But if I ran that, it would still blow up. Why? Because I need to tell the program what module or library or Java program I need to go go get my code. So I can say eulerlib. All right, so now I'm saying, hey, go to eulerlib and go grab those functions. Okay? So now I run the code, and it runs just like it did before, only now I'm really modular, because not only have I taken my logic and separated that out into functions, I have an Euler library, where that square of sum and sum of square, never a problem ever again. Got that problem licked, wrote the code, put it in a library. Now all I have to do is make sure that library is in the directory I'm going to use it, or we learn about packaging when we get more sophisticated. And now I can use it just like we're using that. So basically, we've taken Euler 6, which was this big complicated thing with loops and all the things that we did 2 weeks ago. Right there, we've done it in 2 lines. Okay? Technically not, because we had to write a library first. The library is really no great shakes. We've taken a number from the command line, an integer, and then we send that integer to our 2 library functions that they're going to find us the sum of the square and the square of the sum. Come back, we determine the difference right there in the print line, and voila. I'm not even using the STD out. I should do that, but I'm going to leave it the way it is for now. Okay? So real quick, I don't want to belabor the point. I don't want to get nuts. I don't want to sit here make this video a half hour long. This is it. I wanted to show you that as we gain more facility with the language and we learn more about computer programming and how to design programs and modularity and different things like that, we can go back to the old examples and the old thing we did and think to ourselves, hey, is there a better way to do this? Now, to my programmer brain, this really looks like the solution. Because now I have, if we ever run into a problem that needs square of sum or sum of square, we have this library here that we're just going to use that library. We're going to drop it right in there, and we're going to be able to use that functionality. Here, we just really quick wanted to find the difference, so we did it. And it took us one line, too, because we wanted to take in our limit. Okay? So that's Euler 6, and that's kind of the way, after you've been coding for a while, that you would tackle that particular problem. If you can compartmentalize logic and do it with a function, you definitely do so. And if you can relate those functions together because they have a common task, in this case, working with Euler problems, you can make a library out of them, put them in their own separate file, and then have that module around to use when you need to solve problems. All right? All right, then I'm going to get out of here. You be good and keep your eye out because I'm going to do that digital audio video and drop it next week. And then you can take a look at some of the things we're doing with, I don't know why my phone is just talking to me. And then we can continue to look at some of the different cool things that we can do with Java while we're learning the basics of the language. All right? All right, you be good. Bye.